Well, hey, welcome to the last video for chapter 4. We're on section 7. Love this right here. Starts on page 33 where the notes begin, because this is a great summary and really the hope and goal that both Ms. G and I have for you in your understanding of how to prove triangles congruent. Can you look at each of these pairs of triangles and go right down through the list and say, oh, that's side angle side. Oh, that's side side side. That's angle angle side. You can't prove that. It doesn't work. Just to be able to assess those. It's not just instinctive. You can't just look at that and say, oh yeah, because they all look congruent. The question is, can you prove it congruent? And we talk about the whole rainbow chart over there, being able to make sense of problems and persevere in solving them, reason abstractly and quantitatively. The mathematical thinking that we want you to get out of this is so vital. It's not just, can you look at something and say, yeah, that looks pretty good. Can you prove it? Can you make an argument for why you think these two triangles are the same? Because that carries over into all kinds of other life situations. Okay, enough of that. Let's get back to the actual math. So as you look through those, look at the answer key to make sure you can get those same things. But I would really suggest trying to do this page on your own and match it to the notes. Just don't go to the notes and copy those things in. Okay, what's the rest of this notes 7 all about? Skipping on ahead a few pages, we get to triangle proofs and CPCTC. I've talked about what CPCTC stands for before, but it stands for corresponding parts of congruent triangles are congruent. So if you have two triangles, let me expand this out a little bit. When you're being asked to prove parts are congruent, that means here are two triangles. I think this side is the same length as this side. Well, if these sides correspond with each other, and if the triangles are congruent, then you know the parts are congruent. So first, you have to prove the triangles are congruent. So really, when we're working through these problems, it's just an extra step thrown in. We go through and say, yep, so for instance, this one right here, it almost looks like triangle, but it's angle. It looks like what they're asking you to do here is prove that BCA, they're asking you to prove that this angle is congruent to angle DCA. They're asking you to prove those two angles are the same. Well, you know what? If you can prove that this triangle is the same as this triangle, then you'll be able to say just automatically this angle is congruent to this angle. Let me give you an example of how it works all the way through. I think the one that I want to do is number 3 for you. Let's go through and see if we can prove the triangle's congruent first, then we can prove that the angles are congruent. So what I'm going to do is put a small little dot where it says prove XWV, that's this, hey, that's this angle right here, is the same as angle XYZ. They are wanting us to show that those two dotted angles are the same. Now, let's talk to these triangles, annotate these triangles. It tells us that X is the midpoint of WY. X is the midpoint. Does that mean that this and this are congruent? Yeah, because that's what midpoints do. They cut things in half. It also says that X is the midpoint of VZ, which means VZ, X is the midpoint, so these two are the same. All right. You know what? Isn't it true that this angle is the same as this angle? Aren't those vertical angles? Yeah, so they have to be the same. Oh, now look, you've got side, angle, side. And side angle side is one of our congruency theorems, so I know that this triangle is congruent to this one Because of side, angle, side. Now, let's write it down. Let's give the reasoning behind all this. So the first thing I'm going to say is x is midpoint of wy and vz. Give me a second here. Pages, that's 30. I want to make sure they didn't split that into, perfect. So x is the midpoint of wy and vz, that's given to us. So that means wx is congruent to yx. Wx is congruent to yx. Why is that true? Because that's the definition of midpoint. That's what midpoints do. Does that also mean that xv is congruent to xz? Yes, it does. And that's also the definition of midpoint. And now, isn't it true that angle x here equals angle x here? But I've got to label them better than that. So I need to now figure out how to write these. I think what I'm going to do is go from w to x to v along the single congruency mark to the double congruency mark. So wxv, angle wxv is congruent to yxz, congruent to angle yxz. And that's true because vertical angles are congruent. And now I have a side angle and a side. So now I can say that the triangles themselves are congruent. So that means triangle WXV is congruent to, what is the matching triangle for WXV? Well, if I start here at the angle that I want, move along the 1 to the middle to the 2, then that's the exact same thing as triangle YXZ. That is true because of side, angle, side. And now that the triangles are congruent, can't I then say, well, then this particular angle that I have dotted in red has to match this other angle dotted in red because corresponding parts of congruent triangles are congruent. And that is it. All right, hope that works for you. As always, send me some emails and let me know how I can help you out. See ya.